Hello, this is Mr. Stansbury. I'm going to take you through the 11H notes. All right, so number one, find the density of a metal with mass 10 grams and volume 2 centimeters cubed. Okay, so here's our density formula. Excuse me, and it's always mass divided by volume. And it's usually found in grams per centimeters cubed. And look, this is grams and centimeters cubed, grams, centimeters cubed. So we're just going to put the mass on the top, which is 10. So we got 10 grams over 2 centimeters cubed. 10 divided by 2 is 5 grams per centimeters cubed. All right, that is the density. So that means every cubic centimeter, a little cube of centimeter, 1 centimeter by 1 centimeter by 1 centimeter block is going to be 5 grams of that metal. All right, B, same idea. It's got a mass of 2 grams and it's got a volume of 1.5 centimeters cubed. So we will take 2 and divide it by 1.5, and then we will see what we get. 2 divided by 1.5, and we get 1.333. Or let's do 1 1/3 grams per centimeters cubed. Okay? Okay, moving on to number 3. What volume is occupied by a lump of metal with mass 3.62 kilograms, has a density of 11.6 grams per centimeters cubed? So, they give us the mass and they give us the density. They want us to find the volume. So, let's do that. So, we've got the density, we know is 11.6. And that's going to equal the mass, which is 3.62 divided by the volume. And that's what we're looking for, right? So to get the V up on top, multiply both sides by V, right? And then we got to divide by the 11.6. So divide by 11.6. And we get volume is going to be 3.62 over 11.6. And officially it's 3.62 kilograms, and that's the 11.6 is the grams per centimeters cubed. So what would probably be a wise idea is we've got this in kilograms and this is in grams, so we want these two to be the same. So let's convert our kilograms into grams. So we've got King Henry died unexpectedly drinking chocolate milk, right? So we've got kilograms to grams. That's 1, 2, 3 spots to the right, so that's going to move over. So our 3.62 is going to move over 1, 2, 3 spots, so 3.620 grams over 11.6 grams per centimeters cubed. Now we can divide that out and find what we've got here. So we got 3.620 divided by 11.6, and we get 312.1. We'll call it, let's just call 312. 312. The grams cancel out, the centimeters cubed comes back up, so 312 centimeters cubed would be our volume. Okay, let's move on to the next one, number 4. Find the density of a cube of chocolate with 2 sides that are 2 centimeters and mass of 18 grams. So we've got density equals the mass, which is 18 grams, over, we don't know the volume, so we actually have to calculate the volume. So the volume of a cube with 2 centimeter sides is going to be just 2 times 2 times 2. Oops, 2 centimeters, right? So our volume is going to be 8 cubic centimeters. So we take 18 divided by 8 cubic centimeters, and that will be our density. Okay, so 18 divided by 8 gives us 2.25. So we get 2.25, and that's going to be grams per centimeters cubed for part A. Okay? For part B, we got 15 centimeters by 8 centimeters by 4 centimeters rectangular block of metal. So let's do this. Let's start off by finding the volume first, because that's what we did over here anyway on A. So volume of a rectangular block of metal is going to be, our volume is just going to be the length times width times height. So that's 15 centimeters by 8 centimeters by 4 centimeters. Okay. So let's figure that out. We got 15 times 8 times 4 gives us 480 cubic centimeters for the volume. Okay, gives us the mass is 9.6, so we've got density is going to equal excuse me, the mass, which is we're at 9.6 kilograms. Let's turn that into, we got to turn that into grams. Right, so King Henry died unexpectedly drinking chocolate milk, right? So we got to move that thing from kilo over to regular old grams. 1, 2, 3 spots to the right. So we can move that over 1, 2, 3. So that's 9,600 grams. So our density is going to be 9,600 grams divided by 480 cubic centimeters. So then our density will be 9,600 divided by 480, and we get 200 grams per cubic centimeter. Okay. I just went back and double checked my numbers here, and look, I put one too many zeros in there. So instead of 200, that's going to make it 20 grams per centimeters cubed. Okay, not 200. I say that sounded like a lot, but okay, 20 grams per centimeters cubed on that one. All right, moving on to number 6. Determine the depth of a rectangular block of metal whose base is 7 centimeters by 5 centimeters if the block has a total mass of 1285 and the metal has density 7.5. So this here, if we're trying to figure out the depth, that's and we already have the length and the width, that's talking about the volume, right? So we know the density and the mass, so let's figure out what the volume is, and then we can use that to figure out what our depth is. Okay, so the density is 7.5 grams per centimeters cubed, and then that's going to equal the mass, which is 1285, and then over the volume. So multiply both sides by V, right? So we get V times 7.5 grams per centimeters cubed equals 1285 grams. Sorry, my handwriting's getting kind of sloppy here. Divide both sides by 7.5 grams per centimeters cubed, and that will tell us what the volume is, right? 0.5 grams per centimeters cubed, because the grams are going to cancel out. Centimeters cubed is going to come back up. So that will be 1285 divided by 7.5, and we get 171.3. So the volume is 171. Let's go with 33. Let's see, that's cubic centimeters. Okay, so again, we know that the volume is the length times the width times the height. So let's do this. Volume equals length times width times height. So we know the volume is 171.33. Let's just call the length 7 centimeters. This is centimeters cubed, right? And then this is 5 centimeters times the depth. We'll call that times D. Okay, so we get 171.33 cubic centimeters equals 35 centimeters squared, because centimeters times centimeters, times the depth. So we divide both sides by 35 centimeters squared. 35 centimeters squared. And then that's going to end up giving us some number. Look, there's our 171. Just hit divide by 35, and we get 4.895. So let's call that 4.90. 4.90. And if you notice, we've got 3 here, 2 there, so that leaves us with centimeters for the depth. Okay? Okay. Moving on to our last one here, number 7. If a polystyrene spherical beads have an average diameter of 0.6 centimeters and the density of polystyrene is 0.15 grams per centimeters cubed, estimate the total number of beads present in a box containing beads with a total mass excuse me, of 8 kilograms. Okay, so look, we got centimeters, grams, and then we got kilograms here. So we usually like it in grams per centimeter. So first thing I want to do is I'm going to take that 8 kilograms and turn that into just plain old grams. So that's our King Henry died unexpectedly drinking chocolate milk, right? So kilograms over to grams is 3 spots over. So 1, 2, 3. So that's going to be 8,000 grams. All right. Okay. So let's see, what do we have? We have has an average diameter of 0.6 centimeters. So, and it's a sphere. So we can actually figure out what the volume is. So let's do that. Let's see the volume of a sphere. Okay, let's look up our formula here. Okay, so here's our volume of sphere formula, 4 pi r cubed. So again, the only thing we need is the radius. And so that if the diameter is 0.6, that means that the radius has to equal 0.3 centimeters, right? So we've got 4, so the volume is going to equal 4/3 pi times 0.3 cubed, right? And that's centimeters, right? So let's put that in our calculator and see what we get. 4 divided by 3 times pi times 0.3 to the 3rd power. And that gives us 0.1131, we'll call it. 0.1131, and that's centimeters cubed. So that's how much volume one of those little spherical beads takes up. It's really small. Okay. So, let's see, we know the volume. We know the density. Okay, and let's see, we know that so let's figure out what the mass of one of these spheres is, right? So we've got density. Let's do this. Density equals mass over volume. So our density is 0.15 grams per centimeters cubed. And then our mass, we do not know yet, of one ball. We know the total mass that we have in the entire box, but we want to figure out what one little bead equals. So the mass of one bead, but the volume we know is 0.1131 cubic centimeters, right? So to get mass by itself, we want to get rid of this 1131 cubic centimeters. So we multiply both sides by 0.1131, right? And those go away, and that will give us what our mass should be. Okay, so there's our 0.1131. Multiply that by 0.15, and we get that the mass is pretty small, 0.1696. Wait, I think there's a 0 in there. Yep, 0.01696. And then let's see, that was we multiplied the centimeters cubed, so those went away, and we were just left with grams. Okay, just double check my number here. Yep. Okay, so that's our mass. So now that's how much one little ball, one little bead's going to take up. So we know we have 8,000 grams total in our box. So to figure out how many total beads there are going to be, we do 8,000 divided by our 0.01696. And that's grams, and that will equal the total number of beads, right? So Look, we already have that number in there, so let's take 8,000, and we're going to divide it by our answer. And that gives us 471,570 beads. That's a lot of beads. Okay, now if you happen to be checking this one in the back of the book, the back of the book actually has 417,570. So actually 417,600. The book, like someone just transposed the two numbers. They just got them mixed up. So the 471 is correct. If the back of your book still says 417, feel free to actually write in your book and write it as 471. Okay? All right, if you have any other questions, please feel free to ask in class. Thanks.